Okay, so now the last section in this unit, and it's actually 9-6, not 10-6. Quadratic formula. So we've been solving these things, like these, using graphing, using square roots, the zeros by factoring, right? There's another way to do it. Sometimes you cannot factor them. When you get those weird answers like 11/4, square root of 21, things like that. You can't factor that, you can't graph that, you're not going to get it right. So we have a formula for this, guaranteed to always give you the answer, called the quadratic formula. And we know this is standard form, so once you are in standard form, again, you can't do this unless you put it in standard form first. So if I have 2x squared plus 3x plus 4 equals 0, I can identify some stuff. I can say, well, this is A, the number in front, right? Could be a 1, could be any number. This is B, the number in front here. And this is C, the last number of the term all by itself. Plug those A, B's, and C's into this formula and solve it. And that'll give you the zeros. Notice there's a plus minus here. That means you're going to do one version with a plus sign, one version with a minus sign, and get two answers, potentially. We'll discuss that later. So for now, I copied down the formula. I'm going to do an example in the next slide for you. So on here, I've got 2x squared plus 3x minus 5 equals 0. So standard form, that's the first thing. Make sure it's in standard form. In front of the x is 2, so that's the A. In front of the x all by itself here, and that's not x squared rather, is 3, so that's B. And then C is minus 5. Plug those numbers into the formula here. Again, look at the last page if you need to look that formula up. Memorize that formula. And I'm not kidding. Memorize it. So plug them in. Your B's go here. Here goes your A, and there's your C. Your A goes down here as well. And then solve this. So I want to show you what that looks like solving it. So I'll start out with the negative 3. So what that looks like is I'm going to have negative 3 plus or minus. Inside, 3 squared becomes 9. And then we have 2 times negative 4 is negative 8 times negative 5 is a positive 40, so plus 40. So I do expect you get to know, how to do with that. And the bottom 2 times 2 is 4. Inside, we're going to finish that up. We're going to have negative 3 plus or minus. Inside, 49, all that over 4. Now, here's where we're going to go ahead and break it up. We're going to finish this up, make sure we get a 7 there. So negative 3 plus or minus 7 all over 4. Now we're going to break it into 2, so that means it's going to give us negative 3 plus 7 divided by 4 and negative 3 minus 7 divided by 4. Well, this top one, negative 3 plus 7 divided by 4, that's going to give us a positive 1. And down here, that's going to give us a negative 5/2. So my two answers from this one is 1 and negative 5/2. Those are my two zeros, or my two roots if you prefer, without having to try to factor it, which good luck trying to factor this, right? Now, there's another term here we have called discriminant. So if you recognize the quadratic formula, everything under the square root is called the discriminant. So again, it's the expression under the radical sign. It's used to determine the number of real solutions. So in our last example, when I worked all this, that ended up being the square root of 49. So the 49 is the discriminant. And if that number, so whatever that number is, if it's bigger than 0, there's two solutions. So that's this one. If it's exactly 0, so if I solved all that and got 0, there would be one solution. And if I solved all that and it was less than 0, so a negative number was under there, no solutions. No real solutions, I should say, because we currently can't take the square root of a negative number. We'll do that later, but not today. This piece is more for your edification. Here's why it works. I'm not going to make you generate this. I'm not going to make you memorize this. But here's why it works. If we take this, so again, take your quadratic equation. So the coefficient of x squared is 1, right? And basically the idea is we work to solve. We find that as we work to solve, and I'll let you follow your way down this, as you work to solve, we find that we really end up with this formula when we solve for x. And again, you can follow the algebra here, adding the same thing to both sides, right? And then taking the square roots over here of this piece and pulling out the things that are perfect squares, giving us this. So That's why it works. I'm not going to make you derive that. It might be kind of fun, but no. Something that's really important, though, is this piece right here. Make sure your quadratic equation is in standard form before you use the formula. So if there's anything on the, it's not equal to 0, it's not standard form, right? So standard form first. So another example of the quadratic formula in use. So again, standard form here, right? This is not standard form yet. So I'd have to rewrite it so it is standard form. So moving that 2x over, it becomes x squared minus 2x minus 8. Please note A is 1, B is negative 2, C is negative 8. So then you plug those numbers in, right? So here's your formula. You plug them in. And again, keep track of all your negatives. So again, here B was negative 8. And it's already a negative B, so that means it's a negative of a negative, so pay attention to that. And then again, negative 2 in here again for that. And then A and C and A again. And go through and work everything underneath. And I expect by now that you're able to do that, right? I expect that you know that negative 2 squared is a positive 4. I expect that you can multiply here and get 32, and then add together and get 36. Again, square root of 6 is 36. And we get two versions out of it, right? We get a plus and a minus. So that is important that you do that. And that gives us our two solutions there. And paying attention to the discriminant idea, looking whatever's underneath it there, if that's positive, that means I'm going to have two answers. Before I can start this one, I can see it's not standard form because it's not equal to 0. So I have x squared minus 4x minus 21 equals 0. Now I have to identify some stuff. Go through and, let's see, you need to identify A, B, and C. So A is 1, B is negative 4, C is negative 21. So I'm going to plug everything in. Again, I brought the formula along for you. So we're going to have the opposite of B, which is negative 4, plus or minus, then under the square root, B, which is negative 4 squared, minus 4 times A, which is 1, times C, which is negative 21. All of that over 2 times A, which is 1. So I get, now these two cancel each other out, so I get a positive 4, plus or minus underneath here, 16 plus 84, all of that over the number 2. So we get 4 plus or minus square root of 100, all over 2. So again, that breaks into two pieces. 4 plus 10 over 2, and 4 minus 10 over 2. This becomes 7, and this becomes negative 3. I think it's negative 6 halves, then it becomes negative 3. So there's our two answers. Again, x equals both of these, so that's what you'd want to put. X equals 7 and negative 3, and there's your answer. Okay, so the idea of practical applications, again, a story problem, really, which this one actually is a little more valid, assuming, wind speed and things like that. So in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by this equation. Look familiar? Kind of like turning our other ones upside down, right? Where x is the horizontal distance in meters from the athlete, and y is the height in meters of the ball. How far from the athlete will the ball land? So we're looking, where's this thing going to land? So our two zeros, right, here and here, that's what we're looking for. And so we just basically take this formula, make sure it's in standard form, which it is, and you plug in, right, your A, B, and C into this formula. So again, B is 0.84, A is negative 0.04, inside here, and C is 2. Again, there's A in the bottom. Work the math, right? And when we get done, we find that we have two solutions, a negative and a positive. Since we're discussing distance, that makes no sense to have a negative solution, which is technically over here somewhere, right? Versus over here, the positive solution where it lands. So when I give you a story problem like this, really I'm saying plug it in and solve and look for the answer that makes the most sense. Okay, so I started this problem out with everything plugged in here. So say a batter strikes a ball. The equation is this, right? Where x is the horizontal distance in feet the ball travels, and y is in feet, height in feet of the ball. How far from the batter will the ball land? Round to the nearest tenth of a foot. So again, our formula, identifying A, B, and C from here. There's A, B, and C. Plug those in. So again, A, Obviously going here, there's A, there's B, and there's C. And now we're going to work that one out. This one you might want to grab your calculator for. So we're going to end up with x equals, with x equals that 0.7 on the outside plus or minus on the inside 0.49 plus 0.07, all that divided by negative 0.01. X equals, now we've got negative 0.7, oops, I did drop it up here, didn't I? Be careful of that. Plus or minus. Anyway, so, again, grab your calculator for this. Work on the stuff inside. 0.56. Square root of that is 0.75, again, rounded, because it's like 0.74, blah, 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 you know. So we're going to round that. And then, once we reach this point here, we have a plus and a minus. So we're going to have negative 0.7 minus 0.75 divided by negative 0.01, and negative 0.7 plus 0.75 divided by 0.01. And that's going to yield two answers, a negative 5 and 145. Obviously, the negative 5 is useless as far as an answer goes, so this one gave you a different rounded answer here. I rounded up just a hair more. Again, 145, that's going to be feet. Again, distance has to be positive, so that's what we're looking at here. The hardest part, again, determine your A, B, and C, plugging in and then not messing up when you do all of the math. On this one, again, a calculator was pretty much essential. So a couple more things along these lines. We've talked about a lot of methods here, right? You could graph. You could find the square roots. You could factor. You could complete the square. We could use a quadratic formula. And in this case, again, this one we're doing today, if all these other methods are too difficult to do, like it's going to have a weird answer, this is when we use the quadratic formula. Or some folks like to jump straight to it. Use that. It's a little more math work, but in the long run, it's guaranteed to give you the answer. So in this slide, we're going to take a look, choose the appropriate method. So which method works best? We have 3x squared minus 9 equals 0. Square roots here, no x in the middle. This one's nice and easy, so we might, again, use square roots in this case. Then, this one, taking a look here, there is a center term here. This one's easily factorable. So we could use factoring, and again, take those two factors, set them equal to 0 and solve. This one, you could graph it, I guess. And this one, you can't factor it. You can play with it all you want and find out you're not going to factor it. Quadratic formula. This one, quadratic formula. You could complete the square. You could graph it if you want to. It cannot be factored, though. So, again, I always go to quadratic formula. And then this one, quadratic formula looks like it's going to be the best since you're not going to be able to factor it. And graphing it would be kind of a pain, I think, but you could still do that if you really wanted to. So taking a look at these, which method would you use? This one's easy to factor, so use factoring. You could use quadratic formula if you want to. This one, we're going to have perfect square here, so square roots makes it, and there's no x term, right? So that would be pretty easy to do with square roots. And then this last one, you could use quadratic formula. You could graph it if you wanted to, but again, you're not going to be able to factor it, so I always just jump straight to quadratic formula in that case. Okay, down to that idea of the discriminant. Remember, the discriminant is that piece of the formula that is underneath of the square root. So, how many real number solutions does this have? And again, before you're able to do anything, you have to write it in standard form. Then you just take that piece from underneath the square root symbol, right, underneath the radical, and plug in your A, B, and C here. So your B being negative 3, your A being 2, your C being 5, and you find you get negative 31. Think about trying to take the square root of negative 31. It's going to be not a real number, right? An imaginary number. So therefore, there are no real solutions. In other words, if I were to graph this, it will not go below or will not intersect or go below the x-axis. Therefore, there are no real zeros, so no real solutions. Alrighty. So in this next one here, before we can start, you have to put it in standard form. So I've got 6x squared minus 5x. Move that 7 over, becomes minus 7 equals 0. So now we're in standard form. A is 6, B is negative 5, and C is negative 7. Promise that's a negative 5 there. There we go. Alrighty. So plugging them in. Remember, what we're looking for is the stuff underneath the square root sign, right? So that was b squared minus 4ac. So we plug those in and we get negative 5 squared minus 4 times 6 times negative 7. That gives us 25 plus 168, which is 193. Since this is bigger than 0, it has two solutions. So that's the whole point in the discriminant. Second part here, if A is positive and C is negative, how many... So, on here, again, if A is positive and C is negative, how many real number solutions will the equation have? Explain. Well, obviously it's going to be 2, because if A is greater than 0, right, and C is less than 0, then when we plug this in, again, you got to kind of think about it, you're going to multiply it out, it's still going to be bigger than 0. And B squared, right, which automatically makes it positive, minus this number, right, is going to still be bigger than 0 is the idea.